Hi, my name is Ella Wright, and this is the project that I did with my partner Anna Blackwell called Using Over a Decade of Data to Win the Boston Marathon.
These are the contents of our presentation that we're about to go through. We're going to begin with phase one. Quick background of the Boston Marathon, where we wanted to generate valuable insights about the past races that we could use to predict how the perfect conditions could be if we wanted to win a future Boston Marathon.
So those variables that we're looking at include external and internal variables that all affect the race performance of the different competitors in this. And so we're trying to find the ideal conditions of those variables in order to have the best race performance.
When collecting our data, we looked at a bunch of different websites. First was GitHub. That was where we were looking at participant finishing times from a set of years. We looked at Wikipedia, found every race winner's year, course distance, and country of origin. We took a comprehensive API from a weather API that gave us race day weather conditions. And then finally, we looked at the official Boston Marathon website. The modules we used for cleaning were requests, CSV, JSON, pandas, NumPy, and beautiful soup.
Moving on to phase two, we filled our downloaded dataset requirement by downloading from GitHub the results from 2001 to 2012. These were separated into different files, so we had to compile them into one large data file in order to be able to compare throughout the years.
For our first web collection requirement, we took our Wikipedia and we scraped it. The inconsistencies we noticed when we were looking at two tables of men's race winners and female race winners were that our distance column was a little bit messed up, where we had the distance only being applied to one row where it didn't apply to the others. So we fixed that and made sure they would apply to all the ones after them. We also stripped any of our rows in our notes column to be called to say null instead of just being blank.
You can see this on the slide where on the left you could see how the men's winners data was compiled, and on the right it's the same just for the women's data. So we compiled those into different tables in order for us to be able to analyze that. Our third data set and second web requirement collection came from a weather API where we filtered out different columns that did not have an effect, or we couldn't quantify the effect that it had on the runners, such as the time zone, latitude, longitude, wind degree, because we found that they weren't relevant.
And then we made our weather main column into a Boolean so we could see, instead of seeing a literal number for how much rain or snow was depleted, we could just see if it was true if it was raining or snowing, or false if it was not. And now we're going to go on to phase three. Phase two, we decided to make one revision. At first, when we had worked in phase two, we had cleaned our data and just put it in a table. But then when we moved on to phase three, we realized it would be much easier if we had written the tables to CSV files. So you can see we did that just to make it easier for insight use and data visualizations.
Next, we'll move on to the data analysis and visualizations, starting with insight number one. So on insight one, we specifically were looking at that is rain or snow Boolean column in comparison to the average finisher time of the years in order to determine if and by how much the rain or snow affected the average finisher times. You can see that the rain did have an effect on the runners, but not in the way that we thought it would. So it turns out when it wasn't raining, the average finishing time was actually 10 minutes slower than the finishing time for when it was raining. We didn't expect this, but we're thinking a possible reason is that the rain kept the runners refreshed and allowed them to maintain a faster pace. Our next insight looks at the median finishing time of the men and women and compares it to the finishing time of the winners from each year. So looking at this table, you can see that women needed to be around 35% faster than the median woman's finishing time in order to be the winner, and men need to be at least 38% faster than the median men's time to be the winner of the race.
For our third insight, we counted the number of times a finisher completed the race and grouped them by their country of origin, just to see which countries held the greatest number of finishers. And from this, we found that the United States, Canada, Germany, Korea, and Great Britain were the top 5 countries that runners came from. Specifically, just highlighting that the United States and Canada had about 220,000 finishers in the years of data that we analyzed. And this made sense just because Boston is in North America. For our third insight, this kind of connects to our second visualization. We created a pie chart that organized the winning runners by their country of origin. So even though over 220,000 participants were from the United States and Canada, Kenya and Ethiopia combined carried about 27.63% of the winners, and the United States, not surprisingly, carried about 33.1%. In our fourth insight, we were trying to see if there was a trend in female participation, as we could tell from our Wikipedia tables that we scraped that the women did not start participating or were not allowed to participate in the marathon until 1966. And clearly from the table that we created, you can gather that between the years of 2001 and 2012, the participation by women has steadily increased. We created a visualization to demonstrate this, where we compared male and female participation and found that the spread between male and female participation gradually evened out over our 12 years of data.
And we continued looking at the differences between gender in visualization 3, where we were looking at the finishing time of winners. You can see on the bottom right the scatter plot that shows over time how the finishing time of winners has decreased, and we were able to see as female participation has increased, their finishing time for the winners has decreased, particularly in 2014, where you can see the outlier bottom right. That's probably because of the buzz around the Boston Marathon due to the previous year's bombing.
In our fifth and final insight, we looked at the world record and course record mentions in our winners data and found the percentage compared to the total number of races ever run, and gathered that in order to even break a course record or world record, the chances of doing that are 2.76% for course record and 0.276% for world record. So clearly not a very surprising statistic, but a very low one.
Going on to the conclusions, we can see that the ideal conditions for winning the Boston Marathon is to run while it is raining, and that you also need to be around 40% better than the median of your gender in order to be the winner. Also seeing that the times are getting faster. So if you wanted to win the race, you should probably run it next year instead of in 10 years.
And then just to sum up everything we've learned in this class and our greatest challenges, I think both of us can both agree that we had to push ourselves a little bit beyond what we were comfortable with in this project and had to look for help in our TAs, the handouts we were given in class, and a little bit beyond the course material, where if we couldn't really figure out how to do something, we needed to Google it, and it really pushed ourselves beyond what we were expected.
But yeah, thank you for the opportunity for this project. We definitely learned a lot, and please enjoy these photos of us on the first day of school this semester.